let us begin. Uh, Today I'll be beginning with the fresh chapter that is called as stack data structure. Okay, let me just go through the introductory part of the stack first. Then we will go into the implementation part, how I can apply that stack data structure in actual relevant applications. Okay, all those things you will see in the coming classes. Now I'll be concentrating on the concept of stack. What is stack? How a stack works? Or what are the different applications of stack? Only conceptually. Okay. So let me start. Whenever you feel like you're not following, you can please stop me. Okay. Now, um, I hope the screen is visible. If not visible, please let me know initially only. Don't tell me after the class. Don't tell me after the class. Okay. Let me know whether the screen is visible or not. I will start this. I'll make this a bigger screen. Whether the screen is visible? Yes. Thank you. Now, what is this stack about? You can see in the clip art that I have added, a girl is standing in between the two stacks of books. Okay, you just try to remove the yellow color book at the bottom. Okay, you just try to remove the yellow color book that is available at the bottom, or this book from over here. Okay, what will happen? Definitely the pile of books that are there above it will fall on the girl. This is what is a stack data structure. It talks about you can put the data, you can store the data, or you can store any content from the top end. And when you are trying to remove it from the top end only. Don't try to disturb the bottom end. Okay. If you try to disturb the bottom end, the whole of the things will be collapsed like anything. This is what is stack data structure. It talks about doing all the operations from one end. Okay. So what is a data structure? First of all, before I go into the stack data structure, what is a data structure about? Obviously, data structure is, I think I have covered this in the introductory part. Okay, but let me just glance through the points. Data structure is a way to store and organize data. See, why do I need to organize the data? Can anybody answer this question? Why do I need to organize the data? Why there is a requirement of organization of the data? Can I not, can I not have unorganized data? If I have unorganized data, what is the problem with unorganized data? Can anybody answer this question to me?
When it is organized, ma'am,
Yeah,
it is easy to find whenever required, ma'am.
correct. Whenever I want to find it back, I can easily locate it. If you just disorganize, throw the books like anything. If you want to search for, you have to search through every book until you get the book that you want. This is the need for structuring of data. That's why storing and organizing is so important. Okay. So in other words, when I talk about what is data structures are mainly used to store the data. Okay. And they are stored in a proper manner, in a manner in which I can access the data very easily. So very important reason for that, accessing the data becomes easy. This is why I require structuring of data. Otherwise, I don't require it. Okay. Now, how many types of such data structures are there? So if I want to arrange my data in a proper format, if I want to arrange my things in the proper format, what are the different ways in which I can arrange them in proper way? I will group them into two types. One I call it as linear and the other I call it as non-linear. When I talk about linear, I talk in a single direction. I will be talking about in the single direction, either from the left to right, right to left, top to bottom, or bottom to top. It is unidirectional. When I start thinking about linear data structure, straight line it is. Straight line. That is called as linear data structure. The second one talks about non-linear. This talks about I will not arrange them in any linear fashion. I will arrange them in a categorical form. Okay, suppose I just want to arrange the students in this format. Students I can group in UG students, PG students. UG students again I can group in first to 8th semester. PG students I can group in first to 4th semester. See, this is called a flow diagram, a kind of flow. When I draw a flow chart, it looks as a tree. Okay, and the contents are arranged or organized in the hierarchical manner. This is called as non-linear data structure. Okay, so when I talk about linear data structure, do you have encountered any such kind of linear data structures till date? Have you encountered any kind of linear data structures? Please let me know. Array, before array also, Nandita, you have come across what are called as primitive data types. Primitive, anything that stores data, that is called as a data structure. I call it as a data type. I call it as a data type. A simple data type, int, if I want to store a single value in a variable, even that is a data structure. Okay, so primitive data types that you have come across till date, all of them are linear data structures, linear primitive. There are some data structures which are non-primitive. Examples of non-primitive you have given already. Strings, arrays, structures, unions. All these are linear, but they are non-primitive. Okay, there are primitive data structures like int, float, double, long double, or void. All those things are called primitive linear data types or data structures. Non-primitive linear data structures are arrays, strings, structures, unions, and now I will add stack, queue, linked list. Okay, and there are non-linear data structures which are either hierarchical or they may be something called as hybrid. When I take up hierarchical, I talked about tree. I want to group in the proper manner, okay, in the levels. If I want to arrange the data in the level format, they are called as hierarchical. There is something called as hybrid. Hybrid has both linear as well as non-linear, both linear as well as non-linear. Such examples are dictionaries, hash, okay? All those things, they come under hybrid non-linear data structures, okay? So with this background, let us go ahead with what is stack about. When I take up a stack, as I mentioned, stack talks about doing everything, do all the related operations from only one end. Don't disturb the other end. This is what is stack. Okay. So stack is linear non-primitive. Previously we have come across already. Stack is linear non-primitive. Okay. Stack is linear non-primitive. It is linear non-primitive data structure and it follows all the basic operations to be performed from only one end. Only one end is accessible. The other end is seized. You cannot have any kind of operations done in that from that end. This is what is a stack about. So how do you feel stack looks like? How do you feel the stack looks like? Okay, there are many operations. Among them, the most important operations available in stack are push and pop. Okay, what is this push? Pushing is nothing but insert a new element, add a new data into the existing stack. Okay, pop means already existing data I want to remove or I want to access. That is called as popping. When I'm doing this push and pop, I require what is called as isEmpty. If I try to pop an element from an empty stack, it is an error. That is called as isEmpty. Okay. Similarly, when I want to put new data into the stack when stack is full, that is called as isFull. You cannot push the data once the stack is full. Okay, so these are the various operations on the stack that are to be performed. Other than this, if you want to check where my current top of the stack is, okay, where currently, what is the number of elements that are available right now, that can be checked using what is called as peek, P-E-E-K. Okay, so that is one more operation that is available. That is an extra operation available in the stack. Now, how my stack looks like? See, you can visualize a stack in the left to right fashion, right to left fashion. bottom to top or top to bottom. Anyhow you can visualize it. Here I have drawn left to right. Okay, you can just see over here, this is the last element that is pushed in, and this is the first ever element that need to be removed before I can access to this element. Okay, before I can have the access to this element, I have to pop in these things. Now the question comes, where and when this stack is useful? Stack is useful in everyday activity. Everyday activity. Okay. For example, you are running a browser. You are running a browser. In the browser, you have clicked on a button. In the browser, you have, browser means Internet Explorer, Google Chrome, Mozilla Firefox, whichever. Okay. In that Google Chrome, you have pressed on a button. That button has popped one more window. Has popped one more window. You might have seen that. Until and unless you cancel that window, you cannot go back to the previous window. You have seen it many a times. This is the best application of stack. Until and unless the topmost window that is appearing, that goes off, until unless that is done, you cannot go to the bottom element. So this is the clear application of a stack. One more application I can tell you. There is a main function. Main function has function F1. Function F1 has function F2. Okay, you just can imagine like this. Main function has called F1. F1 in turn has called F2. So where my current location has to be? It has to be inside F2. To come to F1, F2 has to return. F2 has to be ended. You cannot come back before ending F1 because it is recursive, one inside the other. Main has F1 inside, F1 has F2 inside. Until F2 completes, it cannot, the context cannot come back to F1. And until F1 completes, it cannot come back to main. So this is also an application of stack. Okay, we see it every now and then. Then this is called as LIFO data structure. Why it is called as LIFO data structure? You can just see the last element that has come in is the first one to go out. Last in, first out. Okay. So you can just see there is a pile of ice creams the man is holding. Okay. If he wants to eat, the bottommost ice cream first, all the top ice creams will go off. So from where he has to start? He has to start from the topmost. Okay. Now, you can just see if I want to add the elements, how the elements will look like. Empty stack will look like this. It will look like this. It is empty. When I add 1, it looks like this. When I add 2, it looks like this. And who will be the first one to go out? 2 will be the first one to go out. That is 2 is the last person to enter, but first person to go out. Okay, that's why the stack is called as last in first out data structure or LIFO data structure. Or stack is also called as a single ended data structure where every time you have accessibility to the top end. Nothing else other than that. Is this introduction enough for you? Have you understood this much? So what is a data structure about? What are linear, non-linear data structures? What are the different types, categories, subcategories? Then how a stack looks like? Okay, I have not gone into the implementation part of it. I have given you only the instances of stack usage. Okay, thank you all. Next, I will go to, so it is called as LIFO data structure. So next I have what is called as how can I implement the stack. Okay, there are two ways in which I can implement a stack. The two ways, it means in any case, any data structure when I take, any data structure has two ways of implementation of its operations. Which are the operations of stack? Push, pop, is full, is empty. So all these have to be coded. Implementation means have to be coded. How can I code them? You can code them with the intention that it works on a set of arrays, or It works on dynamic data. Data can be added or removed any number of times. There is no limitation at all. First thing that I talk about, limited stack. So when I talk about limited stack, I call it as array. So stack can be considered as an array. Stack can be considered as an array. Just have a look at the things when we went back. So can you call each element that is entered here as an array element? So array is growing like this. When you want to delete, you shrink the array like this. So this kind of implementation where I talk about array implementation, I call it as static implementation because array is static. The size remains fixed. Okay. So I call it as static implementation of stack. So what can be the other way of doing the implementation? The other is dynamic, where elements are getting added and deleted from the only one end, but there is no restriction on number of elements. There is no restriction on number of elements. That is called as dynamic implementation. That you will see in the 4th chapter of your syllabus, linked list. Okay. So I call it as using linked list, the dynamic implementation of stack. This part I'll be taking up in 4th chapter, not now. Okay. So hardly in a week or so, I will be completing stack. Then in 2 or 3 days, I'll be completing queues. Another 15 days, you will be able to write linked list program for implementing stack. Okay. Now, so two implementations are there, either static or dynamic. When I talk about static, I will take simple array and implement it. I will imagine stack as an array. Dynamic implementation, where there is no restriction at all on the number of elements that can be stored or removed from the stack. That is called as linked list. Okay, that is also a linear data structure. But there, the memory locations are dynamically allocated, unlike in case of arrays. Now, so before I get into this implementation, I will just talk about few of the applications of stack that we will be implementing. Okay. So first of all, checking parenthesis, that is the balancing in an expression. For example, if I write a plus bracket b minus c, is it a valid expression? Tell me, is it a valid expression? A plus opening bracket b minus c, is it a valid expression? No. Why not? Because closing bracket is missing. This kind of checking, it is done by stack. This we will be implementing. Okay. Then we have very important implementation of stack, or very important application of stack, which is called as infix to postfix conversion. What is this infix? What is this postfix? We will see in the next week, coming week. Okay. Then we have something called as reversing a given string. Reversing a given string, suppose you have been given a string, you don't have any inbuilt function strrev, then you need to write that code for reversing the string. But stack does it so easily. When you have its functionalities, push and pop, defined, predefined, it can be done so easily, reversing a given string. Okay. And checking palindrome or not, all those things can also be implemented using stack data structure. Then we have many more other applications which you can see every day. Very important ones are redo, undo features in any kind of editor. Okay. Redo, undo. If you do something, you want to undo that. The thing that is done most recently will be on the top of the stack. If you press undo, that will be removed. Next undo, if you press, the next operation previous to previous that which has been performed, that will be removed. Okay. Then you have forward and backward feature in the web browser. In the Google Chrome, when I press on the back button, it will go to the most recent. It will not go to the first page. You go on hitting the back button, it will be in the decremental fashion. This is the best application of stack which we see every day. And other than these things you will not understand now. Okay. Has anyone solved this Sudoku? Even that works on stack. Okay. So any doubt in the things that I have dealt with? Any doubts? Otherwise, we will go ahead with implementation of stack. Any doubts you have? Please let me know. No doubts in the introduction part? No doubts? Yeah. Um, Primitive and non-primitive. What is this, Suraj? What you have typed? Primitive and non-primitive. You're not clear with
I
what is
mean,
called as
linear data
primitive.
structure.
Huh. Why they are called primitive? Why they are called non-primitive? You want to ask that?
Yes,
Yeah.
yes, ma'am.
See, all the basic types, data types are called as primitive data types because they are built in. They are built in into the first ever C compiler that was designed. Okay. Since years it has come. Based on those basic data types, all other things are derived. Okay. Array is a derived data type. Using the basic data types, when I derive something, that becomes non-primitive. Okay. So starting from int, float, double, char, void, these 5 basic data types are called as primitive because they are they are inculcated in the C compiler, like our body has eyes, nose, everything. Okay. They are primitive. When I put glasses on it, that becomes non-primitive because even the glasses are useful for me to see the things, but the glasses are extra things. So non-primitive are extra things that I wear on my body. The the kind of the dress that I'm wearing, that is non-primitive because I'm deriving that based on my body size, my body shape. Okay. So non-primitive is something like that. Based on the basic features, whatever you have got, they are called as non-primitive. They don't have that basic features, but they have some extra features other than the basic. Okay, I hope you got the answer, Suraj. Yes, thank you. Now, shall we go for the implementation part? I definitely know that it will be only half today, but let me begin that. Shall we go for that? Or you want me to stop? What do you suggest? I just want to continue this. I will continue with the implementation. Thank you, Nandita. Okay, let us go for implementation of this. So first, let us look at the way in which I can implement the stack using arrays. Okay, is the screen visible first of all?
Yes, ma'am.
Yes. Whether the font size is okay for you? Okay. So let me go ahead in the thinking that when I take up a stack, okay, just have a look at this diagram. When I take up a stack, so this tag, it just looks as if it is an array of elements. Okay, it's an array of elements. When I look at this kind of implementation where I feel that stack is an array, when you look at this whole of the stack, what are the basic features of the stack? Components of the stack. When, when I can make that array feel that it is a stack, there are two things which talk about the characteristic of the stack. Okay. First thing is the place where I'm trying to store the element, that is an array. The place which holds the values set of elements, the place where the set of elements are stored, I can call that as an array because I'm talking about static implementation. Then when I want to add the new element or delete the existing element, I will be concentrating on the top of the stack. On the top of the stack. So the basic characteristics of a stack are: stack has an array, And in that array, from the top end, either I will add or delete. So when I talk about the stack data structure, it talks about two characters or two data members in it. What are those two members? The first member talks about array, which holds the set of elements, and the second, the pointer or the variable, which holds the address of topmost element. Okay, so I can call that as a structure. So I will implement this stack using structure. You can very well implement the stack with the direct usage of array and top separately. Okay, definitely you can do that. But I just want to have a polished implementation of data structure. Okay, when I look at, because I want to create my own data type by name stack. With that intention, I want to create structure for that. You can very well write like this. Just have a look at this. You can very well write like this. Stack is an array. So let me consider I'm storing integer elements. Let me take it as stack of size. You can very well implement like this. Not an issue. It is not at all an issue. Okay. But I want to create a data type of its kind. And wherever I want, I can utilize that. That's why I want to create a structure. Okay. Structure creation is only for the sake that you can name it with your own name. Okay. Any doubt at this point, guys? Please let me know why I have written structure. Just for the simple reason, I want to convert the stack into a separate name data type. That data type, I want to rename it of my own. Okay. Only for that reason, I'm creating this structure. Now, what may be the members of the structure? How a stack looks like? Stack has two properties. One property, the place where the elements have to be stored, that is an array, and the point from where I have the starting or ending of the accessibility of the elements. So I can call it as, see, you can create an integer array, you can create a character array, you can create whatever type of array you want. Okay. For instance, right now I will be concluding that stack being the static stack, I am using the array as integer array with the intention that it stores only integer elements. Okay. Now I will name it as stk of some size. Okay. This size has to be defined. Let me define this size as, say, 5, for instance. Okay. Initially. Then let me write second property of the stack, that is top. What is the first property? The place where the elements have to be stored. The second property, the point from where the accessibility begins. Okay. So I call it as top of the stack. Top of the stack, and the array becomes the exuberant or the overall properties of a stack. They put together becomes one new data type, which is called as a stack data type. Again, this stack data type is non-primitive derived data type, but linear. What is stack data type? Meaning it is non-primitive and also derived. Why it is derived? Because I'm sorry, it is non-primitive user-defined data type. Why it is user-defined? Because I'm creating a structure and I'm giving user-defined name. Okay. Under this, two members I have given. The two members talk about the property of that stack. Other than this, I will not put anything else. When I look at the stack, stack has place where the elements to be stored and the point from where the accessibility begins. Only two things. Okay. Is this part clear? Is this part clear? Any doubt over here? Please let me know. Any doubt? Guys, any doubt? No doubt. So I will proceed ahead then. Can I proceed ahead? Or you want me to write a simple program which talks about passing of arguments, all those things? Or structure, can I take it afterwards? Or can I write a structure program initially only? See, I want to take the toughest program first, then you can modify that later. Okay, simple array implementation using function passing and the local variables, that can be done very easily. But now I want you to create your own data type, use that data type to implement the stack. This is what is the intention with which I have given this. Okay, now I will close this chat. Okay. Now, what I have done, I have created a structure by name stack. Stack has two properties, the place to store the data and the accessibility point of the stack. Now, when I take a stack, empty stack always has no elements. And all of you know that. Okay, quickly tell me, if I insert the first ever element into an array, what is the index of that element? If I insert the first ever element into an array, what is the index? 0, correct. So if I want to call a stack as empty, can I call top equal to 0? When top equal to 0, what is the meaning of that? That when top is pointing to 0, it means that stack has one element. When top is pointing to 0. Okay. When top is pointing to 0, it means that top is pointing to the topmost element of the stack. So can I call it as empty stack? No. The top that I'm talking about, that has to be anything lesser than 0. What it can be? Anything lesser than 0. It means what? Lesser than 0 is -1. So top of the stack initially has to be -1 to call it as an empty stack. Am I talking about content of stack to be -1? No, I'm talking about the pointer top whose index is -1. Because my array indexing begins from 0, the elements cannot be stored at -1 position. It's as simple as that. So if I initialize top to -1, it means that it is my way of understanding. It means that there are no elements at all. That's why top is not pointing to 0. If I insert my first ever element, top will be pointing to the 0th position. So if two elements are there, where the top will be? If two elements are there, where the top will be? Can you quickly comment?
1.
1, correct.
Top equals to 1.
Yes, top equal to 1. So this is the basic knowledge with which we will begin implementing the stack. Okay. Now what I will do? I will simply create one struct stack variable. What is this variable now holding? Variable S is accessible to both the array as well as top. This is the easiness that I have if I create a structure. With the variable S, I have the accessibility to both the array as well as top. Okay. Now, when I create a variable S, what is the meaning of that? S is a variable of type stack, which is of category structure. And this S holds the values that are contained in the stack array as well as top. Now, what I will do is I will initialize the top equal to -1. How can I initialize? Can I write a top equal to -1 directly? I cannot. What I will do, I have the accessibility of top through S. Okay. And since S is a simple variable, I'll use dot operator. S dot top equal to -1. When I write S dot top equal to -1, initially top is equal to -1. Can I write top equal to -1 over here? This I have discussed previously when I started with structures. Can I write top equal to -1 over here? Quickly tell me. Can I write like that? No, why not? Because every time top will be initialized to -1, which is wrong, Okay, so top equal to any kind of initializations have to be done outside the structure definition. Now, when I have S dot top equal to -1, it indicates what? Stack is empty. Stack is empty. So if you want to check for stack emptiness, what is the condition? If s dot top equal to -1, stack is empty. Okay. When can you call the stack is full? Look at the size. What is the size of the stack? 4. When it reaches 3, 0, 1, 2, 3, size -1. When top is equal to size -1, then I can call stack is full. Stack empty is top -1. When stack full, top is pointing to size -1. So stack empty, top equal to -1. Stack full, top equal to size -1. Okay, whether this much is clear for you. Next things I'll continue in the next class. This much is clear for you. Yes.